Okay, this is the second video on problem solving, and in order to find some interesting things to solve, we're going to switch over to section 8.1 and talk about Pythagorean's Theorem. This is actually your first CEP, your first course enrichment project that I'm going to kind of do for you. So if you are getting into the habit of looking at these videos, it's to your benefit, okay? Do you remember what Pythagorean's Theorem says? It says if you have yourself a right triangle, that means a triangle with a right angle here, and if these sides are maybe A, B, and the hypotenuse is usually C, then there's a relationship between the lengths of that triangle. It turns out that if you square the length of this side and you square the length of this side and add them together, you get the square of the length of this side. A squared plus B squared equals C squared. So that's the Pythagorean theorem. It's been around for about 2,500 years or so, and I want to show you a proof of it, okay? And so this is really cool. I've been showing this to students for many years, and it's just kind of a neat way to actually prove a theorem that's been around a long time, and it kind of connects you with some of the great mathematicians who ever lived. And let's see if we can do it. So what you do is you start by making yourself a big square, and then you put another smaller square inside. And the way you do that is you take 4 points that are all the same distance from the respective corners, and then you connect them together. Okay, so you have a small square inside a big square. Once you have that, then you label these lengths. So this is A, and I took all these lengths to be the same length, so those are all A. And then we'll let this one be B, and we'll let the side right here be C. Okay? So now, turns out we're almost done. Well, at least a good part of the way done. It turns out that let me make sure I'm plugged in here. Turns out that all I have to do is I ask, what's the area of the big square? And you remember, if you have yourself a rectangle, and the rectangle is, say, the width times the length, then the area of the rectangle is just L times W. L times W gives you the area. Remember that for any rectangle? So that's true for a square as well. So here I have a square. This length is what? The length of this plus this would be what? A plus B. And this length right here would be A plus B. So the area of the big square is A plus B times A plus B. Agreed? That's the area. Another way to get the area of the big square is by first taking the area of the small square inside, which would be what? C times C. C times C is C squared. And then you have to add on the area of these 4 triangles. Well, I can't remember what the area of a triangle is, but what I do know is that by taking 2 of these triangles and putting them together, I get myself a rectangle. And this rectangle has width A and length B. So if I take 2 of these and put them together, the area of that is going to be A times B. If I take these 2 and put them together, the area of that's going to be A times B. So I have 2 of them. So I have 2 A times B's. See that? And now, a lot of mathematics requires a certain amount of algebra. It requires being able to know how numbers work. So if you multiply 2 numbers together, if I multiply, for example, 3 plus 4 times 5 plus 6, okay, that's 7 times 11 is 77. Agree? That's 77. Another way to get that is you just multiply the 3 times the 5, that gives you 15. You multiply the 3 times the 6, that gives you 18. You multiply the 4 times the 5, that gives you 20. And you finally multiply the 4 times the 6, which gives you 24. And if you add all those up, what do you get? You get 13 plus 4 is 17. Carry the 1. 1, 2, 3, 4, 5, 6, 7. 77. See that? So you get the same thing either way. So that's called foiling. Okay? You foil, you multiply everything in here by everything in here. Okay? So if I do that, here's another way to think about it. If I take a plus b and multiply it by a plus b, you just multiply them together. Just like you do with numbers. You're going to get b times a. Here you get b times b. Here you get a times a. And here you get a times b. And by the time you add all those together, you get an a squared plus a times b plus a b times a. Those are both the same, so that's 2ab plus b times b is b squared. Okay, so it's the same thing you get if you do this. You get a times a is a squared, a times b, and b times a, that gives you 2ab, and then b times b gives you b squared. See that? So let me show you one more way of showing why that's true. If you have a here, b here, a here, b here, then what's a plus b times a plus b? This is a squared. This is a times b. This is a times b. And this is b times b. See that? So by the time you've got them all, you've got a squared plus ab is 2ab plus b squared. So there's yet another way to see why that foils out like so. And now you can see the very last thing to do. If you subtract 2ab from both sides, you get a squared plus b squared is equal to c squared. So there's Pythagorean theorem that's proved for you. Okay, pretty cool. Okay, now let's use Pythagorean theorem in order to do some kind of neat mathematics. And this is all problem solving again. Okay, a guy by the name of Descartes was a person who lived in the 1600s, and he loved algebra. He loved things like x plus 2y is equal to 5. That's algebra. And he also liked geometry. Geometry is circles and lines. You take a straight edge and you take a compass and you make circles and lines. And you probably had a course of that in high school way back. Okay, and Descartes said, hey, I think there's a way to connect these two things. Before him, they were thought to be two totally separate areas of mathematics, but he found a way to pull them together. And here's what he did. He said if you take two lines that are perpendicular, you make one horizontal and you call that the x-axis, and you make one vertical and you make that the y-axis, and then you put numbers along them all equally spaced. So 1, 2, 3. This would be 0, this would be -1, -2, -3, and so on. And same thing here, going up is positive 1, 2, 3, -1, -2, -3, and so on. Then you have what's called a Cartesian, named after Descartes, Cartesian plane. And what makes that so cool is you give me any point on the plane and I can give you the address of it. The address of this point right here would be the point 2, 3. We always put the x coordinate first and then the y coordinate. And so this one right here would be what? -5 on the x-axis, and then 2. Or this would be -5, -3. This would be the point 0, 0. This would be the point 4, 0 right there. This would be the point 0. You always put the x-axis, the x-coordinate first, so it's going to be 0, -3 right there. And so every point, now those are the easy ones. If I choose a point like this, it might be 4.0 23765, comma 0.9875246, something like that. But the point is everything on the plane has its own address, a unique address that gives exactly what that point is. Okay? So, he was the one that invented that. It seems easy enough. You're probably familiar with it, but he gets it named after him because he first thought of it. And now, let's use Pythagorean's theorem to see once if we can get the equation for a circle. Okay? Instead of just using a compass to draw a circle, remember, if you have a circle, the radius is the distance from the center out to the circumference, out to the edge of it. And if you were to draw one, you would put the point of the compass right there, and you would just draw yourself around, you've got yourself a circle. But we're going to actually get the equation for a circle of radius r. Okay? So let's center the circle right there at the origin, and see how nicely I can draw it. That's not too bad. Okay? There's a circle, and I'll say that that circle has radius r. So from here out to the edge at any point is going to be radius r. And we want the equation of it. Okay? And by saying the equation of it is, here's what we want. If the point xy is on that circle, what equation, what relationship does this point xy have to satisfy? Okay, what does it have to satisfy? That's what we have to answer in order to get the equation for that circle. And Pythagorean's theorem will help us. You see why? Because all I have to do is I make myself a triangle right here. And now I know that the radius is r. I guess I'm using a small r for the radius. The radius is r. And this distance right here is x. Since this x coordinate, since this point right here has the x coordinate is x, and this vertical distance is y right there, because the coordinate is y, which means that distance is y. So what does Pythagorean's theorem tell us? It says that if the point xy is on the circle, then what? X squared plus y squared has got to be equal to r squared. So there is the equation for a circle, centered at the origin and with radius r. Isn't that cool? There, we've just solved it. We've just solved ourselves another problem. Now, let me give you a problem. Instead of that one, let's make one a little bit more difficult. See if you can solve this one. Now, instead of the origin, say we start here someplace. Let's just call this the point. A lot of times authors use the coordinates hk for the center of a circle. I don't know why, but we'll do the same thing. So hk, and let's again say it has radius r. I'll say it looks like that. And we want the equation of this circle. Okay, so the distance out here, as before, is r. And we want to know what relationship does x and y have to satisfy if the point xy is going to be on this circle. Okay? Can you generalize what I did earlier and kind of do something similar? Go ahead and turn off the video again, see if you can figure it out on your own. Okay? It's kind of a nice problem. Okay? Here's what you do. You say, well, make sure you've turned it off and thought about it. You say, hey, let's make ourselves a triangle again. Let's look at the x. Let's look at this distance right here. The coordinates of this point, the x coordinate of this point must be x because it's right below this. The x coordinate of this point is h. So here we started at h and we got over to x. So the distance from here to here must be x minus h. Make sense? Similarly, the y coordinate of this point is y. That's the vertical coordinate. the vertical coordinate of this point is k. So to go from here to here meant we went from k up to y. So the distance from here to here, you take the bigger one minus the smaller one, must be y minus k. So now we have this length, and we have this length, and we have this length. And what does Pythagorean's theorem tell us again? It tells us if I square this one, and then I square this one, and add them together, I'm going to get the square of the radius. Like so. So there is the equation of a circle with radius r and with center. Center is hk and the radius has length r. Okay, there it is. Look at this. So you can do an awful lot of mathematics just by practicing the problem solving. That's really what mathematics is just practicing problem solving. Now I've got one more problem for you using this. See if we can do it. I want you to find the circle, the equation of the circle, which goes through the point 9, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. It goes through the point 9, 5, and also through the point 3, negative 3. So 3, negative 3 means 3 in this direction. 1, 2, 3. Negative 3 in this direction, right there. So there's the point 3, negative 3. And when I say it goes through those 2 points, I mean not only does it go through those 2 points, but those 2 points are the opposite sides of a diameter. Okay, you have a diameter that goes straight through the circle, and that diameter goes straight through the circle, and those 2 points are on the two opposite sides of a diameter. So given that, can we find the equation of a circle? Okay, can we do it? Let's see. Let's try to figure it out. Let's see, what can we do? First of all, we need to find the center of a circle, right? We need the center and the radius. Can we find the center? Well, the center has got to be just basically halfway between these 2 points, which means if you move along this line right here, your x value started at 3 and ended up at 9. Here the x value is 3, here the x value is 9, so it must be that if the center here, the center of this line must be exactly halfway between these 2 points, since it's the center of the line. So what's halfway between 3 and 9? If I add 3 and 9 together, I get 12. 12 divided by 2 is 6. So right there is the point 6. Okay? So right there is the point 6. Let's see. 1, 2, 3, 4, 5, 6. I guess it's right there actually. Here's the point 6. So there's the midway point between 3 and 9. What's the midway point between negative 3 and 5? This is 3 down, this is 5 up. What's the midway point? If I take the average, what do we get? 5 minus 3 is 2. 2 over 2 is 1. So here's your center right there. The center is at the point 6, 6, 1. 6, 1. So notice that 6 is halfway between 3 and 9, and 1 is halfway between negative 3 and 5. See that? So there's the center. Now that we have the center, can we find the radius? Well, let's see. The radius is this length right here. Agreed? It's this length. And I can find the radius by using Pythagorean's theorem. because notice that what's this distance? From 6 to 9, this moved over from 6 to 9, so this distance is 3. And this went from 1 to 5, so go from 1 to 5, it goes 1, 2, 3, 4, 5. This went up a distance of 4. So this length is 3, this length is 4. What does that make this length? Let's figure it out using Pythagorean Theorem. R squared has got to be equal to 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. 9 and 16 gives you 25. So R times R gives you 25. What does that mean R's got to be? If R times R gives you 25, that means R's got to be 5. So R is equal to 5. So now we can use this to get the equation of the circle. X minus 6 squared plus y minus 1 squared, see, there's your center, h and k, is equal to the radius. The radius is 5. If you square the radius, you're going to get 25. So there is the equation of that circle. And let's see that these 2 points were indeed on the circle. What did I say those points were? 3, -3, and 9, 5. If I put a 9 in for x, 9 minus 6 is going to be 3 squared. If I put a 5 in for y, 5 minus 1 is 4, plus 4 squared. Yep, sure enough, 3 squared plus 4 squared, 9 plus 16 is indeed equal to 25. If you do the same thing over here, I'll erase this. You're going to get 3 minus 6, you take the x coordinate, 3 minus 6 is going to be -3 squared plus -3. What do I go here? I take -3 and I subtract k. Or I take -3 and I subtract 1. So -3 subtract 1 is going to be -4 squared. -3 squared is 9. -4 quantity squared is 16. Sure enough, you add those together, and again you get 25. So both of these points satisfy the circle. There you go. So you learned how to do some problem solving here, and you also learned some good information about the Cartesian plane and about circles. Thank you.